right, thank you very much, guys. So my name is Alex, and I work for Amazon Web Services, AWS. I'm a principal engineer at RDS, and I'm also managing RDS Red Team. This presentation was also made by my colleague, contributed by my colleague, Martin. So let me give you a quick introduction of myself. So I have been working with MySQL. My background is MySQL. I have been doing MySQL consulting for a long time. I joined MySQL AB 2006. MySQL got acquired by Sun Microsystems, by Oracle. I worked for another consulting company called Percona. And I joined Amazon Web Services about 2 years ago. And when I joined, I created a new team in Amazon Web Services. I created the RDS Red Team. And my colleague, who is unfortunately not here, his name is Martin. He has been doing database research for 17 years and working on penetration testing of various AWS services. So let's start. So the topic of today's discussion is database penetration test, a database pen test. And a typical way of thinking about how do we pen test a database, or how a hacker will try to access the database, is by directly connecting to the database. So let's imagine the port is open. And if the port is open, someone will try to get in. So the typical protection is setting up the firewall, making sure that the database is not accessible. But there is another way, and another way is SQL injection. And SQL injection is actually much more typical situation. With the SQL injection, a hacker will come in through the application server, but then will be able to get into the database. So here is the example of SQL injection, pretty obvious one, and pretty bad one. This is actually me looking at this example with this, how come? Right? So this published field is getting directly from the user, is coming directly from the user, and an SQL query is being built by concatenating a string. So this is very bad because anyone can put anything in there. And this SQL injection will look like this. So in this case, we are appending a union to the select statement and trying to get a password. So this is MySQL, and MySQL stores the username and passwords in the MySQL.user table. So if we will be able to append a union statement to our normal select statement, we'll be able to potentially retrieve username and password. And if we'll be able to retrieve a username and password, we can actually do anything with a database. But that's too easy, right? So typically, with a well-configured application, an application user doesn't have an access to the system database. A system database, MySQL database, is isolated. So now let's take a look at the sample fictional scenario. In this fictional scenario, we have a company that is storing a health records, PHI information. And this company also has a WordPress website. A WordPress website, there's nothing interesting there. It's information about the company, it's all static content, but they have the database for that WordPress website hosting on the same MySQL database as the health record system. So let's imagine the bad actor was able to use WordPress and was able to get into the database by the means of SQL injection. WordPress is notorious to having all sorts of vulnerabilities. So when we get into the WordPress, normally we'll not be able to access the health records database because it has its own user. So we have a user-level isolation between this corporate, nothing interesting website and the real health records data. The question is, how do we get here in our pen test? So to explain how we will try to obtain this information, I will need to go through the specific problem which is called confused deputy problem. And confused deputy is actually a computer program. And we use some method to confuse this program to give us more privilege that we are entitled to. So to demonstrate this, I will first use the Linux OS. So in Linux OS, we have a cron jobs, right? And what we are trying to do here is we're trying to fix a problem. We want to make sure that a user, an unprivileged user, in this case EC2 user, will always have files in its home directory owned by itself. For example, if some administrator made a mistake and put a file in the home directory owned by root, we need to fix that, right? So we created this cron job, run every minute to find files owned by anyone else but this EC2 user and chown it. So that's good, right? What can go wrong? So I have recorded this video to demonstrate what actually can go wrong. So let's see if it will work. All right, so here I have this cron job running, and I specifically created on root, from root, I have created a file. So this file is owned by root, and I want to fix this. So the cron job will fire in a minute, and it will actually fix that. So let's wait. Let's see if it will work. Not yet. Not yet. And here we go. So it's fixed. Now a bad actor on the other side of the screen will create a symlink. Anyone can create a symlink actually pointing to any file on the file system. So here, a bad actor will create a symlink pointing to etc password. So I created a symlink called password, whatever, in my home directory using this unprivileged user. Now, what will happen is our cron job will start, follow that symlink, and chown the etc password to unprivileged user. So unprivileged user will be able then to edit the EC2 password file to get a privilege escalation. So in a second or couple seconds, it will actually do the job. So now it has changed the username, changed the ownership for the etc password. So now unprivileged user can edit the etc password and do whatever. It can rename it, it can put the ID to 0, making it root, and stuff like that. So what happened here is that we have actually used a confused deputy problem, right? So we have confused our normal cron job to do something, and it didn't know that it's doing this, to do something to get a privilege escalation. So let's see how this applies to the database. And what we will do is we will attempt to do the same with the MySQL database. So again, our goal is to somehow get to this health records database in MySQL. And we want to try to actually retrieve the password from the MySQL user. But this MySQL database is protected. So let's see more details. So if I'm a database administrator, I can retrieve all this information, right? So, and then I can see that I have number of users here. I have admin user, I have corp WordPress user that only has an access to the WordPress database, and there is nothing interesting there. I have another user, which is called health data service user, which has an access to the health data information. This is my target. But also interesting here, I have this weird monitor user. So what is this? So let's take a look and list all the privileges. Again, on the WordPress, we have a dedicated user, which only have an access to the WordPress database. We have a healthcare database, its own user. But we also have a monitoring user, which have all privileges. Well, it has a global select privilege. So monitor user can actually retrieve the information from the MySQL system database. But it can also execute. It can execute the stored procedures. It can execute functions. So the question is, how do we confuse our monitoring user into doing something malicious, into giving us an additional privilege that we don't have? So normally, we don't have the ability to select from the MySQL user. So if we will try to do that from our corp WordPress user, we cannot select the username and passwords. But if we will do that from the monitoring user, we can see the actual username and password, just because this user have a global select privilege. So what does this user do, and what are the systems that this user is used for, right? So MySQL and all the databases sometimes have another system which is called database performance monitoring. So performance monitoring collect the database metrics, collect the slow queries, and generate explain plans. And that is one of the reasons why this MySQL monitor user needs to have a global select. And database administrators are usually using this monitoring system to review the database metrics, to collect slow queries again, and they run explain plan to understand why the query is slow and try to optimize this query. So let's take a look at the typical select query. So this select query have a subquery there, in and another query. If we run an explain plan on that query, what will happen is that MySQL will generate the explain plan and give you the metrics so that you can understand why this query is slow. It will give you an information about how many rows are being scanned, what indexes are being used, and stuff like that. But the question is, it should never re-execute the select again, right? That will be bad. So if we run explain, it will not re-execute it. Well, actually, in some cases, it may. And this is what has been detected by Percona, a database consulting company. They have found out and published a blog post which is called Uncommon Sense MySQL. So what happened is that if you have a subquery inside the query, and you run the explain plan, MySQL will actually execute the subquery part and materialize that. The reason why it's doing that is to provide the actual metrics, how many rows it will scan. Without materializing the subquery, MySQL will not be able to understand how many rows MySQL will need to scan for the final execution. So what happens here is that we created a select sleep statement. And we run explain, and it hangs. So that means that this select sleep subquery is being executed. So this is bad, and this is also not good for the data consistency. It can create a DDoS attack. But the question is, how do we use that in our confused deputy hacking attempt? So again, let's look at the picture again, right? So we want to escalate the privileges. And to do that, we will generate a slow query, make it slow, put something inside of that query which will retrieve the needed information, and then we hope that either the performance monitoring system or a DBA will pick up this query and execute it. So we have our privilege here on the corp WordPress user. We have all privilege on the WordPress, but nothing else. Remember that here, if an attacker was able to compromise and get the SQL injection and get the access to the WordPress, the attacker will be able to create anything inside of that database. I can create table, I can create stored procedure, I can create stored function, and so on. So my goal will be to generate a slow query and wait until someone will run explain. So how do I craft that slow query? So I have an option to create stored procedures, and I have an option to create stored functions. We will start with this function, call it exploit. And this function has this SQL security. SQL security basically say which security context this function will be running. Invoker means that whoever runs that, the content, the queries inside of this function will be run in the content, or in the security context of whoever runs it. Invoker. Invoker meaning whoever runs it. So inside of that function, I can select my password, well, anyone's password, from the MySQL user. And then I will actually want to make it slow, so it will be picked up by the monitoring system. So I'm checking here if the user who is running this function is monitor, then I will retrieve the authentication string. If it's not running by my monitoring user, I just make it slow. But now the question is, how do I get the password and save it? How do I retrieve this password and send it back to me? To do that, I will create another function which will have a different security in it. So there is a notion of definer. And definer is actually sort of similar to suid on Linux. So when I specify the definer, this function will be running in the context of my user. So I will craft my main function, retrieve the password, put it into the save function, and the save function will be running as suid. So it will be running in the context of my user, and my user have the ability to insert or update or whatever. So here's the final proof of concept. I create an exploit function. I put an SQL security invoker there. Then I check if the user is monitored, and if the user is monitored, then I will execute my exploit. I will select the password for the admin user or for the monitoring user, and I will save it into my own table. And if it's not monitored, then I will make the query slow. Right? So I have recorded this video, which actually have this demonstration of this proof of concept. So I have everything prepared here on the hacker side of the screen. And I'm running from the context of unprivileged user. Then I will, this is the table, which I will store the password. And then I will craft my query, my slow query. So I have this subquery, and the subquery will actually just do call of my exploit function. This query will be slow, 3 seconds. Because it's slow, someone will pick it up. It will be either a monitoring system, which will automatically do explain plan, or a database administrator. So in this case, a database administrator found this slow query and tried to understand why it's slow, and it runs explain. And then the DBA is confused. It's not slow. It's weird. There's no tables, whatever. But now our hacker, our attacker, has the password. So we have successfully retrieved the password for the monitoring user. We have confused the monitoring system to give us an additional privilege, which we didn't have, and retrieve the password for the monitoring user. If we have a password for the monitoring user, in theory, we can reconnect to MySQL and dump the whole health metrics database. The only problem is, this is not the password. This is the hash of the password. And MySQL is not actually, this is the original implementation of the hashing algorithm for MySQL, and MySQL doesn't do a very good job of using the right cryptographic functions. So what's next? Fire the hashcat. So let's see. So I use this RockU list of passwords, and we'll see if it will work. So I took this hash of the password, removed the star. The star is MySQL specific. It just means that it's using the specific algorithm. And we'll run the hashcat. All right, let's see how fast it will work, because this may take a while, right? Hashcat is slow, going through this megabytes of data. Here we go, it's done. So the monitoring user has a password which is pass, right? How come? Well, the thing is that maybe common. The monitoring users are created by different people. They may be created by MySQL database administrators. And the monitoring users may not be treated as real MySQL database users, right? They're only used for monitoring, nothing else. But in this particular case, we successfully use the confused deputy problem to retrieve the hash of the password for the monitoring user. used the hashcat to very quickly brute force the password, found out that the password is pass, and now we have reconnected to the database. And we will be able to actually, it's simple password, easy to crack, and now the result is we will be able, the attacker will be able to download the whole health metrics, well, health records database. So why this was possible? One of the reasons is that MySQL explain actually executes the statements. But the second reason is that monitoring user has a select and execute privileges. This is one of the big concerns here. If the MySQL monitoring user will not have select and execute privilege, this will not be possible. So here's our final picture. In our case, the bad actor was able to download the health records database. So that's MySQL, Postgres. I don't have a proof of concept on Postgres yet, but it's theoretically possible. So my plan is, and our plan is to research more and see if the similar problem affects PostgreSQL. So finally, when we have an access and we completely compromised the MySQL database, or we assume that we did compromise the PostgreSQL to the point where we have a super user on the database, what's next? So the next is we'll try to obtain the access and escape from the database to the operating system. We assume that this database is running on Linux, and we will try to obtain a reverse shell. Basically, the attacker will try to get into the database, into the operating system without the direct access to Linux OS. So how? We have an admin or root or super user privilege to the database, and now we need to execute a command, a database command, from the unprivileged user. One interesting consideration comparing MySQL and Postgres. In MySQL, if you have a super user, that doesn't mean that you will automatically get a shell access to the operating system. In Postgres, usually it is. So I'll start quickly with Postgres and show you a couple of recorded videos of how that is possible and what we will use. In PostgreSQL, there are a number of ways how we can execute commands from the database, escaping from the database to the operating system. There is a copy from program, there is an archive command on Postgres. So here's the video which will demonstrate how you can use the copy from program to write a simple file. All right, did it start? Yeah. So first of all, our goal is to write to a file in TMP. So we can see that the file is missing here. There's no such file. So what we'll do is we assume that we have a super user privilege in the database in Postgres, and we will try to write a file on the OS. So eventually, it's very easy. We can create a dummy table. When we create a dummy table, we can use the copy copy to program command to actually write to a file. So we do copy from program and just do touch. Instead of writing a file, we could have run a reverse shell or try to do something else. So now we have created the file. Now the same thing, the similar thing is possible with archive command. archive command is a specific Postgres feature which will allow you to execute an external program to archive the log files. But you can specify the actual script or actual command for that. So we will alter system and set the archive command to touch. Then we will enabling archiving. If you enable archiving, you will need to restart Postgres. So I will restart Postgres, but we assume that this is probably done by system administrator or archiving has been already enabled before we were able to hack into the Postgres. So now when we have enabled the archive command, we have used this archive command to do the touch of the file, and the file has been created. So the next is the reverse shell for Postgres. So instead of doing the touch command, we will execute the reverse shell. The reverse shell will be on the bottom, the listener for the reverse shell will be on the bottom of the screen, and on the top of the screen, we will change the archive command to execute the reverse shell actual command. So when we will do that, we'll need to make sure that the listener, in this case netcat, is on the bottom of the screen, and then it will receive the connection here. So now we have a connection, and we can control the OS. It's the same as SSH. It's just the channel, and we can execute the commands here. So we were able to escape the database and control the operating system. Finally, MySQL. MySQL is more tricky. It's actually not possible out of the box. The MySQL, to be able to actually escape from the MySQL to the operating system, you need to have a specific insecure configuration, which is not the default. But I will demonstrate that anyway. So to do that, what we'll do is we will use the user-defined function, and we will compile a user-defined function, upload it to the host, and then trigger this user-defined function. So this is how it works on MySQL. So first of all, we will demonstrate the file creation in MySQL. That only works with a specific insecure configuration, which is not the default. So what we'll do is we'll create a table, and we will load something into this table. We'll load A, B, C, D in this table. And we can also do that with a hex. It's just the demonstration of that we can actually do binary and insert binary into the table. Right, so we will insert the values here. And then after we insert these values, our goal will be to export this, writing a file to disk. So this is the prerequisite, this is the first step to uploading our user-defined, our malicious user-defined library. So we need to be able to write to a specific directory called plugin dir. By default, there's another variable called secure file prev, and secure file prev should actually be disabled if you want to do this. So now we have written to the shared library to the file, and now we'll see how we can actually execute this. So first of all, we'll need to define a function. We need to define this function, so we will create a very simple dummy function, which will implement the reverse shell. This dummy function, we will compile this dummy function, and we will execute it. we will export it. So now we have compiled this dummy function. We have a shared library. We have a SO file. We will hex this SO file. And we will then, after we will hex it, we will load it into MySQL, and then we'll do select into out file. So this is the actual command execution, right? So we have the shared library, which implements the writing a file or reverse shell. So now we can actually execute this. I hope you guys can see the screen here. So in this particular example, our goal is to create a file into TMP from the MySQL itself, so via the shared library. In reality, we will, instead of doing that, we will just execute the reverse shell. So now we'll select this, and we have uploaded our shared library. So now we can actually select whatever command we have, and now this file has been created. All right, so the final step in our pen test is to move laterally. So now I not only control the MySQL server, but I also control the MySQL process on that server. That means that I can shut down this MySQL running here and put a so-called rogue server. So what I want to do is I want to move laterally from the MySQL server to a client. A client is usually a web server or something like that. So there is a very old known vulnerability in MySQL client protocol, which allowed to read arbitrary file. The way how it works is that our server, our rogue server, can actually trick MySQL client to request an arbitrary file from the client. So again, we control this box, we control the operating system, we can replace our MySQL server with the rogue server. And our goal is to read the file from the client. We may want to read something like a private key from the client, or lots of application servers actually stores the database configuration with a clear text, maybe another MySQL or PostgreSQL server. So this is our goal. So MySQL has this feature and the query called load data locally in file. Usually the client will need to execute this statement. But in reality, we can actually rewrite the statement and run the load data local in file request for any command. So in this case, our client connects to the rogue server, and on connection, it will rewrite the statement to load data local in file. So this is basically the original work, 2018, that has been done to determine that, and they found the protocol, they reversed engineered the protocol, the MySQL protocol, and find there's a capability, client capabilities. So client connect to the rogue server, do nothing, just a connection. And then the server will send the load data local in file request, and then the load data local in file will actually send the file from the client to the server. All right, so this is the conclusions, and this is what we should do to prevent this situation from happening. From the beginning, we obviously need to protect from SQL injections. We'll need to use prepared statements, and we'll need to sanitize input. Never trust the input coming directly from the customer. The second step, our second step was using the confused deputy problem. So we need to make sure that we grant only what is absolutely needed. This whole situation that I demonstrated was only possible because this monitoring user has a global select and execute privileges. But on the architecture perspective, of course, it's totally wrong to store the WordPress database on the same database server where you store your PHI information, the health information. And upgrade your MySQL server, right? Because there are lots of vulnerabilities has been found. And if you upgrade, you need to upgrade your MySQL server, but you also need to upgrade your MySQL client. MySQL client libraries, this rogue server problem is actually on the client side, so you need to upgrade your client libraries. So that's all we finished. We successfully finished our pen test, not only getting the full access to the database, but also escaped from the database to the OS, and even did a lateral movement, trying to attack the client and other systems. So that's all. And the final thing, I'm building the red team. If you are interested in joining AWS, please come to see me. Working on attacking the database, doing the database research and stuff like that. Thank you very much. Yes, and if we have time, any questions?
If anyone has a question, feel free to raise your hand.
Okay, so we'll take one.
We've got time for one question.
Is the monitor mode a default account, or is that relying on a misconfiguration that is common, or what level of, like, how often would you expect to see that?
Yeah, that's a great question. The monitor is not a default account, right? So monitor is sort of an example of what can happen if you will use a database monitoring system. Almost all the database monitoring system will actually either create an account for you or ask you to provide the existing accounts. And I saw cases where people were actually using a root user for the monitoring system, which is obviously wrong. But it's not a default account, but it's common to create one.
Well, thank you, Alex. It was a privilege to have you talk to us. We have a gift from Hack Sydney, and thank you very much.
Thank you very much.